Okay, some applications of piecewise functions. We have a word problem. It says the average newborn resting heart rate is 112 beats per minute and continues to decrease by 2 beats per minute a year until the age of 20. After 20, a person's resting heart rate averages 72 beats per minute. Write a piecewise defined function for the heart rate as a function of age, and then graph the function. And once you have that, what is your average resting heart rate? Well, it says to write a piecewise defined function for heart rate as a function of age. So I'm going to call this h of a. Heart rate as a function of age. And you can see that this has two separate pieces. The first piece is from a newborn until the age of 20. And this is a linear function because we're decreasing at 2 beats per minute a year when we start at 112. So we could write this as a linear equation of negative 2a plus 112. And our age starts at 0 and ends at 20. Now I'm not going to include 20 with this one. I'm going to include 20 with the second part of the function. So the second part of the function says after 20, a person's resting heart rate averages 72 beats per minute. So this is a horizontal line. So this is just 72 because we have no slope. And I'm going to include the age here to be greater than or equal to 20. So there's our piecewise function. Let's graph this really quick. And just ignore the horizontal and vertical lines here. Let's use just the first quadrant. So we're going to create a big first quadrant here. And our horizontal axis is A for age. And our y-axis is h of a, our heart rate as a function of age. So a scale, we're going to start here at 0, and then 1, 2, 3, 4, 5. Just every 5 tick marks, we're going to label. Because we need to really show from 0 to 20 and then what happens after 20. So we just need a little bit more than 20 here. Oops. Okay, and then we're going to put a gap here because really we don't have anything below 72. So I'm going to start this at 60, and then every 2 tick marks up I'm going to increase by 10. And we can stop at 120 because the highest heart rate we're going to have is that newborn heart rate of 112. Okay, so at 0, if you want to just substitute in, if you substitute in 0, which is the lowest number in our domain, negative 2 times 0 is 0, plus 112, so it's going to be a point at 112, which is approximately right here. Oops. Okay, and then substitute in 20. So negative 2 times 20 is negative 40, plus 112 is going to give us 72. So if we go over here to 20 and then go up to 72, which is approximately here, we are going to connect those together. And I would always recommend a straight edge to do that. Now we're still going to be graphing this, so it's going to be an estimate. Oops, you can see I'm a little off there. But it's always nice to have straight lines. And then at 20 and above, we know we're going to be at a horizontal line at 72. And then put an arrow at the end because hopefully we're all going to be living past 20. Put a little curve there. Okay, so there's our equation, there's our function. Now, you can use both the graph and the function to figure out your average resting heart rate based on your age. So I'm just going to pick a number of 16. And no, I'm not 16, but let's try it anyway. So h of 16, Well, 16 is in the domain of our first equation, so we're going to use that one. So negative 2 times 16 plus 112, and if you solve that, you end up with 80 beats per minute. And then you can also look at the graph. Here's 16. Go up to your graph, and there's your point. Oops, go all the way up there. And then go over, and you can see with my graph, I'm just a little bit off. So that's where a graph is giving you more of an approximation, and the equation will give you the exact answer. Let's try something more around my age. Let's do 29, which isn't exactly right. But in 29, that's age is in the domain of the 72, so our answer is 72 beats per minute. And 29 is not on my graph, it'd be somewhere over here, but if I would go up at 29, it would cross at 72, which again would be kind of our estimate.